Well, welcome everyone, including any UCSD friends that might have arrived. Uh, I'm Jeffrey, and come on, you guys introduce yourselves.
Oh,
I'm
sorry.
Jerry.
I interrupted Jerry, and I'm Luke.
And here, we're here to teach you guys about PHP, or PHP Has Problems. All right, so what is PHP? Okay, here's the link, by the way, to the slides. And so here's a small joke for you guys. Take your time to read it. High quality humor from Reddit. Anyway, uh, yeah. What is PHP? Well, PHP obviously stands for PHP Has Problems. Job done. No, in reality, PHP is also a recursive acronym. PHP Hypertext Preprocessor. And so, what is PHP? Well, PHP is a popular general purpose scripting language that is especially suited for web development. So basically, you use it for your website. It is server side and it is integrated with many popular databases such as SQL. So going into a little bit of a brief history of PHP. Basically, PHP was first designed as a set of common gateway interface binaries by the creator, where more specifically, common gateway interfaces are interfaces for web servers to execute command line tools. So like Echo, as you can see in the PHP code. And at the time, PHP stood for personal homepage tools. And eventually it got expanded upon countless times. So the second iteration was Forms Interpreter, where we started to see some of the major features of PHP today. So like the HTML embedded syntax and the automatic interpretation of form variables. And there's a lot of inspiration from Perl at this stage. So that's where all the dollar signs come from. And so, like I said before, they kept rewriting and rewriting PHP. PHP just kept growing. And so at 1996, we reached this stage of PHP. And at this iteration, it was called PHP/FI. And you can see it's kind of recognizable as PHP if you've done PHP before. But you can also see it as HTML comments. So like you can see the HTML comments. You can see some pretty basic things. You can also see the SQL database query over here. And so you can see that it looks familiar, but it makes you want to puke. So that's PHP in a nutshell. Anyway, over the years, PHP just kept gaining more support. So more support for interfacing with databases, more support with interfacing with protocols, and it became a fully fledged language. In the process, it was inspired more by C and then eventually more by C++ and Java as PHP incorporated object-oriented principles. And so basically, this is why there's problems, because PHP grew way beyond its initial scope. And here's a quote from the creator of PHP, Rasmus Lerner, and and I quote him, "I don't know how to stop it. There was never any intent to write a programming language. I have absolutely no idea how to write a programming language. I just kept adding the next logical step on the way." And so when the creator says this, you can tell that PHP definitely has some problems. So the major problem that I think a lot of people like to talk about PHP is the confusing syntax. So for one, functions, keywords, and methods are case insensitive. So you could call string length with random capital everywhere, but variables, constants, and array keys are. So that's just a lot of inconsistency there. And there's even more consistency with the built-in function name. So some functions have the C-style naming convention where they kind of squish everything together. So for example, string length. And other functions use the snake case style that I believe was more common in like Python. So like string underscore split. So it's just really inconsistent for no reason. And another thing is that array is not a function, despite it seeming to be so. It's actually just a construct, so you can't treat it like a function. There's 20 different functions for sorting because they decided that you need every sort imaginable. instead of just letting you program it yourself if you needed to. And then there's also 20 different sorts for looking up, or 20 different functions for looking up C errors. So yeah, just to name a few. And there's some more universal issues with PHP too. So like PHP is weakly typed. That leads to all kinds of errors. And as I'll mention right now, PHP is also designed to not fail. So that is also another source of errors in addition to the weakly typed. Scope is not limited by files. So if you define a variable in one PHP file and then you include it in another, it could just you could just get unknown values that you forgot that you defined. And the PHP, like I mentioned before, is designed to keep running no matter what, like a lot of scripting languages. So that leads to a lot of problems because it's not really vocal about it. It also like fails silently a lot. And the major final gripe is that arrays are supposed to be like the catch-all data structure, where arrays can be maps, they can be hash maps, they can be like basically everything in one. And it's very confusing if you're used to C-style arrays, for example. So for a little quiz here, I'd like some audience feedback. What do you guys think this code would return? Let's see if we can pull up the chat. Here we go. Yes, you would hope that it would be John, but let's run it really quick. Oh, I'm sorry, in So here we go. Oh, this obvious I didn't see. Um, Sorry about this. Let me just do another example where we just evaluate um the booleans directly. So we can have true, which evaluates to 0, and then we can have a false that evaluates to 1 or 2. So you would guess that this would give you 0, but it gives you 2. So, and above here, it would give you Thomas if I copy and pasted it correctly. But the reason for this is because PHP's ternary operator, unlike all other languages, is left associative. So it basically just evaluates the else side of the ternary operator first. And it makes no sense. All right, next slide. And here's another guess for you guys. You guys guess this can do? PHP can die, but it won't. Why would you implement it that way? God knows why they did it that way. But yeah, any guesses as to what this will return? 6, 5, 55 days. All right. All intuitive guesses. 5 days, 5. It will return 10. And let me show that really quick. Wait. I was escape on the wrong monitor. There we go. There we go. And see, it evaluates to 10. And so the reason for this is something that I'll go into right now. It's called type juggling. So it's kind of like the more extreme version of type coercion. Now, what is type coercion? Well, type coercion is basically when in, say for classic C, where you define a double, but you give it an int. So like double A equals to 1, semicolon. And that's a type of, that's what's called type coercion, where it converts that 1 into a double value. Well, PHP takes it further with type juggling, where and it takes the 5 days and it cuts off the 5 because it sees the plus and the integer 5, so it just goes really far out of its way to make things work. And so the way we can really see this is with loose comparisons. So in this giant mess of a chart, we can see that if you would do a loose comparison between an array and false, it would evaluate to true, an empty array specifically. And like there's a lot of these unintuitive types of things here. So for example, like 0 would equal to PHP. It just doesn't make sense intuitively, but if you think about it from the PHP type juggling parser kind of point of view, this makes sense because there's like, oh, there's no number here, so we just cut off all the rest, and that's 0 basically because there's no number. All right. I will now hand off the controls to Luke.
Okay, sorry, let me get my screen up really quick. Hopefully you all can see that. I think so. Excellent. All right, so on top of the just general bad design that Jeffrey talked about and that kind of mired history of PHP, it has a ton of insecure functions. So not only is it a pain in the butt to use, it has a whole bunch of functions that if they're not used absolutely perfectly, can cause arbitrary code execution, which is a big no-no. Letting someone run their own PHP code can be hugely problematic, can print out whatever files they want. They can bring in their own files and do whatever. They can wreak havoc on what we have. So some of the things that insecure functions lead to are object unserialization injection, remote file inclusion. Another one is preg replace and crypt. Thankfully, the last two are depreciated, but I am going to talk about them because there are still tons and tons of websites that are actually running these old functions when they really shouldn't be. So the first one we have is object unserialization injection. And so it does exactly what it says on the tin. It allows for things like code injection or SQL injection via the unserialized function in PHP. This happens if user input isn't properly sanitized. So sanitization is checking, cleaning, and filtering data inputs from users, removing unwanted characters or strings to prevent injections of malicious code. Think, a curly brace or, a backslash if they're escaping certain characters, all that kind of thing. So before we talk about object unserialization, we have to know what PHP serialization is to begin with. So what is it? Serialize on any PHP object. This includes primitive types and the more object-oriented types. Returns a string representation of that object. And the unserialized function called on that exact same string, or with that string as an argument, creates a copy of that object. So it's great if you want to pass an object from one server to another, you pass this serialized string, and then it's reinitialized later on. So here we have serialize 1.1, which is a double. It'll return this as the string representation. And then we have a more complicated one. We serialize this array with PHP has and problems in it. And it gives us this array. We have 3 elements. Here at index 0, there's a string with length of 3, PHP, and so on. Here's the general serialization format. If you want to look at it later, most of them are pretty simple except for objects, which can get a lot more complicated with class names and different fields and the data that they hold at that time. So another thing we need to know when an object is unserialized is how it's instantiated, and these things called magic methods that PHP runs on them. So magic methods are methods that are automatically called on PHP objects when they're instantiated and destroyed. So the wake up function reconstructs resources an object might have. Think a database connection or anything else it might have at the time it was serialized. And then destruct cleans up an object when there is no reference left that it exists. I don't know if you can explicitly call it, but again, it is automatically called no matter what when no more reference to an object exists. So I mentioned this before. When an object is unserialized, a copy of it is created, and then the associated wake up function is found and executed. Same thing with destruct. Note that we can't stop these functions from executing. They're just going to happen on the object when it's unserialized or when it's forgotten in the case of destruct. So where's the problem? The problem is if an attacker can control the exact serialized object or the string that's passed to unserialized, they can control the properties of that object and may be able to hijack an application by controlling the values and what happens in the wake up and destruct functions. Again, these are executed automatically. So the only way to catch it is to correctly sanitize the user input. So here's just one example. We have a user object with 2 fields, username and status. So we have our username, chef, and then their status. This one is user. But if you're able to intercept this, you could make this admin instead. And also, minor mistake here. I'm going to point out my mistake. This should actually be 4 and 5 respectively. I didn't change that in the example that I'm using. So how is this prevented? I kind of mentioned it before. if the serialized payload, i.e. that string, never makes it to unserialize, it can't do anything at all. So sanitization serves to render any payload from an attacker completely harmless. PHP, this is generally achieved with different sanitization filters, with each filter targeting certain characters and strings, either through a blacklist or a whitelist type system. So sanitized special characters will remove all characters of ASCII value of less than 32 and all HTML escape characters. And then sanitized URL will remove all characters except letters, digits, and a set of valid symbols for a URL in this case. Next problem is local and remote file inclusion. This is kind of a big one that is less of a problem with the actual function itself and more just up to the programmer to make sure that they're using them correctly, which can be really difficult sometimes. So this can affect all functions like include, fopen, get file contents, file put contents, require once. This is a lot like object unserialization injection. It happens if you let someone give their own kind of file string and you don't sanitize it, and you don't check that it's valid or that it's allowed in any way. So this can kind of let the user view any the contents of any file being hosted as long as it's accessible. And it essentially is what happens when you let users specifically or specify exactly which file they want to look at. The local refers to the ones that are on the server itself, and remote is when they can actually specify a URL that your web page will navigate to, snatch any PHP code or whatever file from there, and will display it using include, fopen, all that other things. So I have a short demo. Hopefully this is still screen sharing. Let me start this up. I'm going to be using DVWA, which is just for damn vulnerable web application. I kind of butchered vulnerable there. And we're just going to use the file inclusion thing that they have. In this case, it's a lot easier for us because we can actually see exactly the files and exactly the directory that we're looking at. So here we see that it's going to let us look at file 1, file 2, file 3. But note that there's other things here. There's file4.php, include.php. Index is actually the one that's being rendered, or no, in that case, it's actually include. So if I click on file 1, we see it's saying page equals file1.php. You know, we go back, file 2, file 3. We can actually change this and say, all right, you know, file 3, I want to be looking at file 4, and there's nothing stopping me from doing that. It'll just let me look directly at that. But this gets way worse, where we see, all right, we're in this file inclusion directory. We go up, and I've actually included this little passwords.txt file, which is just a simple, well, that's a long notepad window. I just have a bunch of some of the most popular passwords that are used. So if we actually go here and say, all right, I want to go up a directory, I got some spoilers there because I didn't clear that correctly. Passwords.txt, and it'll actually just show these up at the top. Another problem is if we just put in kind of any website we want. So if we go to acmcyber.com, copy that, and we want to actually render that here in the page, take us there, and it'll actually take that PHP code in, render it, and execute it depending on which function is being used. So that's file inclusion. Let's keep going. We also have preg replace. I got another demo for this, but I'm going to talk you through it really quick here. So preg replace is used to perform a pattern match and replace or highlight all of the occurrences of it that are found on a page, typically with user provided regular expressions. And it's often also for filtering out or searching for words or phrases. Think an expletive, it could take it and it could either censor it or it could replace it with, you know, a less harsh word or remove it entirely. The problem, and it's kind of a big one, or it used to be a big one, is that PHP can be tricked into executing the result of preg replace with the E modifier on the regular expression. So it essentially lets you execute the replacement value as code. So you say, all right, select, you know, whatever word, and here's the code I want you to replace it with. And then that E modifier will just take that replacement and run it as PHP code again. Big problem, lets you run any PHP command. You can create a huge, massive problem payload, I guess. Thankfully, this is no longer supported as of PHP 6, I think. But even then, PHP 5 was kind of ruled out only a few years ago. So there are still a bunch of websites that use this. When it was being used, you could use preg quote to combat this, which adds quotes to any scary characters in the input. This makes all regex characters inert. So it kind of defeats the purpose of preg replace in its entirety. So they have to be re-enabled by hand. And just the fact that this preg quote function is here kind of just demonstrates the problem with preg replace. So if we back out and I just go to my script, here I have my preg replace example here. I have Concerning Hobbits here, excellent book. And I go ahead and I have two fields in here that'll let me find stuff. So if I say, all right, I don't like hobbits, not a fan. I want this book to be about dwarfs instead. All right, so I do that. So we say this book is largely concerned with dwarves. You know, you look around, every instance of hobbit has been replaced. The problem is, and to do this, I kind of gotta finagle it just a tad, in the sense that it's depreciated. It's no longer supported, as it were. So we kind of need to trick it into executing what it returns as PHP code. So in this case, we're just going to tell it, evaluate that input. Again, this is not how it works when it was a problem, but we need to kind of trick it because it is no longer replaced. So if I say, all right, take, I want to replace this. So I'm going to say find this and replace it with PHP info, which is a command that'll just print out the info on the version of PHP that's being run. And then I want to comment out just the rest of the page here, which actually isn't very much because it's pretty simple, but that's what we're doing. So when we run that, we see it, we have an unterminated comment, but that's fine. But we see that it did manage to execute that PHP info and show us all the information on it as it's running there. We're going to go back. I got one more function that's a problem. Thankfully, this one is also depreciated, which is the crypt function, problem with PHP 5.3.7. It was used until as late as June 2019. So now it's no longer supported. But again, there may be sites that are still running this. And the problem with this is that if it's being used incorrectly by the programmer, it could allow attackers to bypass authentication with an arbitrary password. This is a problem with if they're using the MD5 hash for the password with a salt of any kind, crypt would return only the salt and not the hashed password, which essentially means if an attacker knows they're using this MD5 hash, they could use whatever password to get in, cause a big problem. I also have the details here if you want to look more into that. And I'm going to pass the reins off to Jerry now.
Cool. Let me share my screen. Okay. So far we've been talking a lot of trash about PHP and how you should not use it or why it's bad and all the different vulnerabilities with it. But if you can see on the right, PHP is still in the top 5 most used computer languages, even though it is on the decline. So why is it that so many people still use PHP, even though there's so many problems? Well, first of all, it's fairly easy to learn. So it integrates HTML directly. So you can actually type in HTML code and a PHP file will render that HTML. So because it's so easy to learn, most beginners like to use PHP as their starting language. And as a result, the beginners usually don't know too much about cybersecurity. So they have a lack of security. So that just causes PHP sites to usually have a lack of security. And PHP is also a very old language. Some websites still use it, such as Facebook, Wikipedia. You can see in the image at the bottom, Wikipedia has this index.php. So that tells you that it is running PHP. Another thing is that most servers can execute PHP code just because of how popular it is. It's kind of like an expectation for servers. And because it's insecure, a lot of people use it to attack other things. So we're going to see a couple of examples on how we can utilize PHP, all the vulnerabilities in PHP to our own advantage. Okay, so we talked about SQL injection last workshop, but many SQL databases use PHP to connect to the other databases. I have an example in a later slide. So if you see a lot of $ in code, especially in front of the variables, it's most likely going to be PHP or something derived from PHP, because for PHP, every single variable needs a $ in front of it. And there's also a lot of insecure SQL functions that combined with insecure PHP functions allow you to be able to break a lot of things. And you guys can enjoy the XKCD about naming your child SQL injection thing. Okay, so this is an example of what like a SQL database would look like on the back end. So you can see that it uses PHP. At the top, it first creates, or it first connects to the database, and then it executes the SQL query using a PHP variable, and then it prints out the result of that. Okay, so now onto a completely different topic. This is about shells. So if you guys haven't heard of shells, they're the layer that connects the user with the operating system. So usually we do that through the terminal. Mac OS has terminal. I think Windows has command line something. And some examples of shells are bash and ZSH. I know for Mac, Catalina, ZSH is the default for the shell. And shell commands are the commands that you're familiar with. They're also known as Linux commands. So they're the pwd, ls, cat, things like that. They're all shell commands, which you can kind of think of as their own language. And because they're kind of their own language, you can write shell scripts that execute a bunch of different shell commands at once. So just like how you can execute like Python in your terminal, you can have like a Python command line thing. You can also execute shell scripts. And you can also upload shells. So shells are files just like anything else. Most of them are written in PHP, which is why we're covering them in this workshop. And you can use them to hack a lot of different things. Okay, so this is an example of a shell script. You can notice that at the top, there's a hashtag exclamation point /bin/sh. This kind of tells you that this is a shell file, shell script. It's kind of like the doc type HTML at the top of HTML files. You can see a couple of shell commands like print working directory, echo hello. You can make a folder. You can create a text file directly in terminal. You can move that into a folder, go into that new folder, print working directory, and then list out all the folders. So you can see here, I'm using ZSH because that's the default for Mac. And if you run that, you just do ZSH and then the name of this file, test.sh, and it lists out everything. Okay, so now onto web shells. So web shells are basically shells that you upload. So most web shells are written in PHP because it has a lot of vulnerable functions. One specific one that I'm going to be highlighting is the system function. So you can see at the bottom, this is PHP code that just system a get command. And then the system function basically executes whatever is inside of it as a shell command. So if you pass in something like ls, this will list out whatever, using the server, it will list out whatever files are also in that directory. And we use web shells on websites that don't sanitize files before uploading. So don't upload a web shell as your CS homework because I'm pretty sure they sanitize the files. And web shells, you want the website or the server that you uploaded to run the file as PHP. So using this web shell, hackers can view, add, modify, or delete files on the server. So this is really dangerous because you can basically directly access it. So there's many open source web shells out in the public. You can probably find a lot on GitHub. I have a link to one of them in the later slides. And a lot of them use code obfuscation. So that's basically making code look really, really complicated and really hard to decode. So this is an example of a web shell. It's not super long, but it looks really complicated. And see if you can spot a couple of the functions inside of it. I know there's like string replace, that's the obvious ones. There's also like get contents over here. There's a return over here. uncompress. Yeah, so a lot of functions hidden inside just a couple lines of code. And now I'm going to be giving a demo on uploading PHP files and Weebly. So Weebly is an example of a web shell. You can check it out using the GitHub link here. But if you want to try it out yourself, you need to first run a server locally, because I don't think any server wants you to upload a PHP web shell onto there. And you need a PHP version less than 8.0 because one of the functions it uses is deprecated by PHP 8.0. So let me share my screen, move on to over here. So this, let me move this around so I can see. So on the right, I have kind of like the server side of, you can see this is what a PHP file looks like. You can embed HTML directly into it as long as you have like something PHP. This is my cool new social media site that is definitely better than Facebook because there is dark mode. And let's check it out. So we can upload a file. So let's say I want to upload a puppy as my profile picture, and we can upload it. Wow, it has successfully uploaded to the server. If you're keeping track on the right side, you can see that there's a new file in the images tab. We can view the photo here. If you click it, wow, that's the photo in all of its full screen glory. Note the URL. It's in a folder called images, and it's called puppy.jpg. So I know that this isn't sanitized, but you need to find something, a file upload that isn't sanitized for you to be able to do anything. So let's upload this file. So harmless.php. This is basically PHP code that uses the system command to be able to access whatever is inside of it. So if we upload it, you can see, wow, it successfully uploaded to the server. So you can see that it does not sanitize the files that you upload. Even though it's a PHP file, you were able to upload it in a place that only an image should have been able to be uploaded. And if you click it, you can see, wow, it echoes hello. It echoes you have been hacked by the coolest hackers. It prints the working directory. So you can see that this server is being run on a really cool person named Jerry's laptop. And you can see what files are in here. So you can see the puppy.jpg that we uploaded earlier, harmless.php, which is the one we just uploaded, and secret. So you're like, that looks suspicious. I want to see what the secret is. So you add a new line onto your harmless.php that basically opens the secret file. So let's go back, re-upload it. And if we upload it and view it, we can see, I did not save it. Remember to save your files, kids. So re-upload it. And we can see, wow, it's a super duper secret message that says Happy Lunar New Year. Wow, who would have known? Okay, so that was basically uploading just a normal PHP file. This isn't a shell because you can't really execute commands. And maybe you're like, I'm tired of always needing to like re-upload and then change whatever commands in here. So let's upload a shell. So before uploading a shell, I would first recommend, because we're using Weebly and Weebly needs a PHP version that is less than 8.0, I have this PHP file, which is really short. It basically just prints out whatever info about the PHP that the server is running. So let's upload this info. And then let's view it. So you can see, wow, it's for running version 7.0. So we know it's susceptible to the Weebly web shell. So let's go back. And to use Weebly, I have the GitHub repo downloaded here. And you can basically do /weebly.py and see what you can do. So basically, you have two main things. You can generate a new agent, and then you can run terminal or command on the target. So what we're going to do is we do /weebly.py and then generate, and then let's choose a password. Let's do password 123 exclamation point, just to be extra. And then we want the path, which is basically the file name. So let's call it actually, no, I already named it harmless. Let's call it random.php. So now it has generated random.php. If we list whatever is in here, you can see that there's now random.php. So let's upload that file onto here. So this is the Weebly random.php. You can see that it's basically the exact screenshot that I had on my slides. You open it and upload it, and then you can view your photo here. You can see there's nothing here. So you're like, what does it actually do? You can see random.php is now in the server. So now we have to connect to it. So to connect to it, we basically use this one, run the terminal or command on the target. So we do /weebly.py, and then we have the URL. So let's copy and paste this URL onto here. And then our password. So our password was password123 exclamation point. And now we're connected. So we can do some things like ls, and it lists out all the things that we had uploaded before. We can see our harmless, our info, puppy, random, and our secret. And now we can do multiple commands without having to re-upload. So you can also see that the server is running on this laptop, blah, 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 blah. So you can, maybe you want to open the secret from here. You can see that secret. You can go back one folder, sorry. And then now you can see, wow, there's an index.php, there's a style.css, and what's this? Sensitive info.txt. So let's open that and see what is inside of it. Wow, it's someone's username and password. It would be really bad if someone was able to access this. So yeah, that's basically the end of my demo for Weebly. Basically, the moral of the story is just to sanitize all your inputs, make sure that people can't upload random things onto your website and be able to upload a web shell. So that is it for this workshop. Here's the attendance code. We also talked about web shells on our Cyber newsletter. So if you're interested in learning more about it, make sure to sign up here and check out the challenges at acmcyber.com. You can make an account and see your challenges. All right, thank you guys.